Okay, so first half of today's lesson, we're talking about how to find the magnitude and direction of a vector. When we first learned what a vector was, we defined it as a mathematical quantity that has a length, or a magnitude, and a direction, or an angle. But you'll notice when we started writing vectors, we were writing them this way, which is not a length and direction, that's an x component and a y component. So we know that in standard form, that first number is how far I go left or right from the origin. The second number is how far I go up or down in the y direction from the origin to build the vector. And if I'm going to the right and then up, I know I'm forming a right triangle because I have two legs that are at 90 degrees. If I connect those endpoints, I get a right triangle. The length and direction are then the hypotenuse of that right triangle, which we're going to label r, because r is the letter we use for distance from the origin. We get the direction by looking at the angle between the vector and the positive x-axis. And the question is, if I have a number for x and I have a number for y, and actually in that picture I think I called it a and b, how do I find the length of the hypotenuse? And how do I find the size of that angle? So we'll start with the hypotenuse. I have two legs of a right triangle. I want the hypotenuse. Which formula am I using? Pythagorean theorem. Very good. Crazy Pythagoras. Because I know that in this picture, a squared plus b squared should be r squared, the hypotenuse squared. Right, that's just Pythagorean theorem. If I want r, what do I have to do to both sides? I undo squares with a square root. Very good. So r is just the square root of a squared plus b squared. Yeah. Or x squared plus y squared. Sometimes you'll see it written this way. That's math 2 math. Yeah. Just this sometimes makes it easier to recognize where it's coming from in the graph. It could be. Angle. How would I find that angle? I have the two legs, a and b, or x and y. Which trig function would I use to find the angle? Sin, cos, or tan? Sin, cos, or tan? Louder, Ethan. Ethan's vote is for tan. Do we agree with tan? How do we calculate tangent? What over what? Sine over cosine, or in terms of legs of a triangle? Opposite over adjacent. Very good. And looking at that angle, B is opposite, A is adjacent. Good. So this should be tan inverse of the opposite side over the adjacent side. B over A. Or, if you're thinking in terms of X and Y, B is up and down, that must be my Y coordinate. A is side to side, that must be my X coordinate. Tan inverse of Y over X. So Pythagorean theorem, tan inverse. Pythagorean theorem, tan inverse. That is how we get from standard form vector representation to magnitude and direction. We're going to practice. If you do not have your calculator out, please get it out. Yes, I do. You are welcome. All right, so example 1. Find the magnitude and direction of the vectors below. And I can see those vectors are already written in standard form. That makes me happy. If my vectors were not already written in standard form, if I was given an initial point and a terminal point like I was in my bell ringer, what should I do before I grab the Pythagorean theorem and tan inverse? Yeah, write it in standard form. Good. When we're doing math with vectors, first thing is make sure they're in standard form if they did not start that way. Good. Ours are in standard form. I know the first coordinate is x, second coordinate is y, and I want to find the length or magnitude of my vector and then the angle. So we'll start with the length. I know my length is Pythagorean theorem, square root of leg squared plus leg squared. And actually, that's going to be approximate. I'm pretty sure 3 squared is 9. 5 squared is 25, so that's square root of 34. Wait, did I do that correctly? No. Yes, 9 and 25 is 34. I can do math in my head. So square root of 34 is 5.8. I see some nodding. Approximately 5.8. Good. And then to get my angle, we do tan inverse of y over x. And because we are dealing with triangles, we would prefer degree mode. And who has an answer for me for tan inverse? 59. Very good. 59.0 something something. Perfect. Very good. I should check when I am finding my angle that my angle sits in the quadrant I expect it to. Because remember that tan inverse is limited to quadrants 4 and quadrant 1. It's only going to spit out angles in quadrant 4 and quadrant 1. If I'm in quadrant 2 or quadrant 3, it's going to give me the supplement to that. I'm going to need to find its buddy on the other side of the unit circle. So we have to check. So positive x, positive y. Which quadrant am I in? 1. Perfect. Is 59 degrees in quadrant 1? Yes, it's between 0 and 90. We are happy mathematicians. Very good. All right. There are 2 more on the board. I am going to give you a couple minutes to do examples B and C in your small groups with your partners. Yes? And I'm going to have you walk me through them. Make sure you're checking your angle is in the appropriate quadrant. Yes, Bruno. Plus, and then down. So it goes to the right and then down. It's in quadrant 4. It should be in quadrant 4. Yes, Bruno. Good. Perfect. Okay. Negative in parentheses. Good. Mm-hmm. B and C, B and C. Give you another minute or two. Yes, Megan. Just e-hall pass. Yeah. There it goes. There it goes. Okay. Yes. Where? Oh, because you can't have a negative under a square root. The square goes outside the parentheses. It is negative 10 times itself. Yeah. Oh, pencil. You're welcome. So if I go to, notice it's sitting where the square root is. I can't take the square root of a negative. Okay. So when you do this calculation, oops, clear. Nope, that's not what I meant to hit. Why can't I do anything today? Luis, would you get up and press stop on that thing before I get frustrated? So it's this one here. Yeah. Mm-hmm. We're going to put parentheses around the negative 10 before we square it. Okay. And then plus, and then the other one is 4 squared.
Thank you.
You're welcome. All right. So most of us have at least one of those done. So we'll go ahead and start with B. We will pull up our name generator. Melanie. Melanie, 4B. How do I find my magnitude? It is the first one.
So square root 2 to the power 2 plus negative 3 to the power 2.
Good. And what did we get? 3.6. Very good. Approximately 3.6. Perfect. Brandy. For example B, how do I find the angle or direction of my vector? You don't know. Jordan, can you help her out? Also don't know. Alan, can you help him out? Alex.
The inverse of tan.
Inverse of tan. Very good. Tan inverse. I know I'm going to have a fraction. I need to know which numbers go in that fraction.
The negative 3 on top and the 1.
Very good. Y over x. Y over x. Very good. And you should get negative 56.3. So the question is, does that put us in the correct quadrant? So positive x, negative y, which quadrant? I go forward and then down. Where do I land? Four, quadrant 4. Good. So is negative 56.3 in quadrant 4? The answer is yes, because we go down from positive x. Puts us in quadrant 4. Sometimes you will see this reported as 303.7. Which is also in quadrant 4, because it's bigger than 270 but less than 360. But that started at positive x and went around in the positive direction, counterclockwise, to where we're sitting. Either of those answers is correct. Good. Next one. Who can I pick on next? Jackie. How do I find the magnitude for vector C? Very good. And what did you get when you did that? 10.8? Can I get a thumbs up if we also got 10.8? Very good. Perfect. We know the next question, and actually I'm going to go back to Jordan now that he's seen one. Jordan, how do I find the angle for this vector? Inverse tan, very good. And in the parentheses, 4 over negative 10. Did we set up our tan inverse the same way Jordan did? I see some nodding. Very good. Y over x. When you do that on your calculator, what do you get, Jordan? Negative 21.8 degrees, which is correct. And we're going to look at C. So C is negative x, positive y. Which quadrant am I in? 2. So I have a problem with this guy. I'm going to draw my coordinate plane. Negative 21.8. I start at positive x. I go down a little bit. So this is negative 21.8. I need another angle in quadrant 2 that has the same tangent. What is the period of the tangent function? Ooh, sine and cos are 2 pi. What is tangent? How often does tangent repeat? Well, for any face, you guys got to have a cumulative final coming up in May. It is not pi over 2. That's too fast. You've got Google, and I know you've got a cell phone. What is the period of pi? Or period of tangent, sorry. Gabe is giggling. I just gave you the answer. It's pi. It's half as often as sine and cosine. Yeah. Tangent repeats every pi. So I know its value should be pi apart. If I want this guy's buddy, I'm going to add pi, which is how many degrees? 180, yeah. Full circle. Yeah, half a circle right there. So the question for us is, what is negative 21.8 plus 180? Where does that put me? And I did this earlier, and I got 158.2. I see some nodding. This is the angle I have to report, because unlike B, where both numbers were reporting the same angle, this angle is in quadrant 4. I need to be in quadrant 2. So this is the only correct direction for that guy. So for tan inverse, if I know that my vector sits in quadrant 2 or 3, I need to add 180 to end up where I'm supposed to be, because tan inverse is only going to give me answers in quadrants 1 and 4. So make sure when you're finding your angle, check the quadrant of the vector. Check your answer is in that quadrant. If not, add pi. Yes. Yes, which is, yeah. Oh, I added the answer that my calculator spit out, plus 180. Negative 21.8 plus 180. Yeah. Just for the last one, because the last one gave me an angle opposite the quadrant I should have been in. Yeah. And that will happen anytime the original vector sits in quadrant 2 or 3. So you can save yourself if you draw the vector first. You know you're sitting in quadrant 2 or 3s, add 180 to it. Happy face. Happy face. Now I'm going to challenge you. So I know how to take x and y coordinates and find the length and direction of the vector. What if I'm given the length and direction of the vector? It's magnitude and direction. How do I write it in standard form? So we're going to do A together. A tells me my vector has a length of 6 and an angle of 42. And I want to write it in standard form. So first thing I'm going to do is draw a picture. Based on that angle, which quadrant is my vector sitting in? I'll scooch you down so you can see the quadrant picture. Which quadrant would an angle of 42 degrees sit in? 1. Yeah, it's between 0 and 90. Good. So I'm going to draw my little picture over here. I know my vector sits here with an angle of 42. I know it has a length of 6. And what I want is the x and y coordinates that that vector makes with the axes. I need this number and this number. So, how do I find x and y? I have the hypotenuse, I have an angle. I want to find x and y. Relative to 42 degrees, what side of the triangle is x? Opposite, adjacent, hypotenuse. Adjacent, x touches the 42 degrees. Which trig function is adjacent over hypotenuse? Cosine. I know cosine of 42 degrees should be the adjacent side over the hypotenuse. How do I find x? Multiply by 6. Good. Get that number out of the denominator. So x is my magnitude times cosine of the angle. Y, I know it's not adjacent. Is y my opposite or my hypotenuse? It's my opposite side. Opposite is which trig function? Sine. Very good. Same principle. Sine of my angle should be my opposite side over my hypotenuse. And I'm going to solve for y. I got to get rid of that 6 in the bottom. Y is just magnitude times sine of my angle. I'm going to give you a second with a calculator. 6 times cosine of 42. 6 times cosine of 42. Ethan, what'd you get? Your calculator should be in degrees because this is in degrees. 4.4 what?
4 and 5.
So 5 rounded up. Good. What about y? 4.0. Yeah, good. Perfect. Perfect. So if I have my magnitude r, my angle theta, x is always going to be r times cosine of theta. Y is always going to be r times sine of theta. always. Consistently. Because when I'm drawing right triangles in the unit circle, or on the coordinate plane, x is always adjacent to the angle, y is always across from the angle. So it's always r cos for x and r sine for y. I'm going to give you a second on your calculators. Same thing for b. All right, Megan. What did we get for the x value for our vector? You didn't get it, frowny faced. Can somebody around Megan help her out? Ellie, what did you get? -2. -2. What did you get for the y, Ellie? 3.5. Can I get a thumbs up? You also got -2, 3.5. I see thumbs up popping around the room. Very good. We should check and make sure that that sits in the quadrant we expect it to. So 120 degrees, which quadrant am I in? 2. Bigger than 90, less than 180, quadrant 2. This has a -x, +y. Which quadrant does that put us in? 2. So we're pretty sure that that's correct. Very good. Very good. And that's it. That's it. That's how we get back and forth between standard form and magnitude and direction. Pythagorean theorem, trig functions. Pythagorean theorem, trig functions, right? They're basically right triangle questions, which you guys have been doing for years at this point, right? Okay. Questions on this right triangle math for vectors? Everybody still awake? Kind of, sort of. I know. Only a couple more days, and then we go back to normal schedule. And a couple more weeks after that, you graduate. Okay, if there aren't questions on 6B, we're going to start 6C together. And then I'll give you some time to work on assignments, get some homework done. Okay. So we're going to talk about several vector math operations. We're going to start with how to add and subtract vectors. We'll talk about multiplying them by a constant. And then we're going to talk about something called a dot product between two vectors. It's kind of like how we multiply vectors. So the first question for today is, what does it mean to add two vectors? And to answer that question, we're going to consider a scenario. You are walking from your friend's house or your house to your friend's house, and you are a nice, wonderful human being who does not trespass. So you're not crossing over fences and hopping through people's backyard, right? You're not breaking into people's houses and wandering through places you shouldn't be. So you're walking along sidewalks to get there, right? So all of your walking is left and right, up and down on a map. I'm only allowed to follow city streets. So to get to your friend's path, you go half a mile east, and then you go 0.6 miles north, and then you go 0.3 miles east. And your path is shown on the graph in red on mine. I know I can't print in color, I'm sorry. The net result of those three paths, half a mile east, 0.6 of a mile north, 0.3 miles east, is an overall displacement of 1 mile at an angle of 37 north of east. And the question is, how did we find that information? So I'm going to give you about 2 minutes. How did I figure out that the distance from your house to your friend's house, straight line as a crow flies, is 1 mile long based on those red paths that you took? Turn to your neighbor. Can we figure that out? 2 minutes. It's on a graph. You guys have skills for that, yeah? How?
Because including here, it's 8.
Good.
And that's how much you're taking us including here.
So this is 8. What is this?
6.
6. What is 0.8 squared plus 0.6 squared? And then take a square root. I would bet you money it's going to round to 1. Pythagorean theorem it. Pythagorean theorem it. I do. I've seen him before. Yeah, it's very cute. I like that he's a redhead. I have a soft spot for redheads. Don't judge me. All right, thoughts, comments. What are we thinking? I heard at least one group say, oh, that's a smart idea. So I know at least one person's figured it out. Where is that one coming from in our graph? Oh? Rise. I just heard rise over run. And I saw Ellie do something very similar. How much total did we go over? How much total did we go up? Yeah, good. How much total did we go over? 0.8, yeah. 0.5 plus 0.3. How much total did we go up? 0.6. And we know how to find the hypotenuse given 2 legs of a right triangle. Square root of 0.8 squared plus 0.6 squared. On a calculator, what does that give you? About 1. Yeah. How do I get the angle? How do I get that angle? You just did it. It's in note 6b. Tan inverse. Very good. Tan inverse of what over what? Ooh, yes. Y over x. Very good. 0.6 over 0.8. On your calculator, what does that give you? Make sure your calculator is in degree mode. 36.8, which rounds to about 37, which is what we were told here. Yeah. In math, commonly we add vectors when we do separate stages, and I need to find the total for a whole bunch of separate stages. So in physics, the net displacement is the sum of all the individual displacements that you took to get from point A to point B. Yeah. We can find the answer then by making a right triangle from the individual pieces and adding. This was nice and pretty because all of our individual displacements were either side to side or up and down. That won't always be the case. So what we really need is a reliable method to add vectors that have components that are not horizontal or vertical. What happens when they're tilted. So that's the game for today. First, some vocabulary. First, that answer, 1 mile and 37 degrees, is called the resultant, or the resultant vector. So when I add or subtract vectors, the answer is called the resultant, because mathematicians like to feel fancy and smart. I'm not going to quiz whether you remember that or not, but if you see it in your book, you should know. Yes?
Why is it that just result?
Because mathematicians like to feel smart and fancy. No, that was a reasonable question to which I don't have an answer because I'm not the one who made up the math vocabulary. I'm sorry. Some crazy old dead guy decided that's what we call it, and now we're stuck with it forever. Like a lot of things in our society, unfortunately. We can find that resultant vector 2 ways. The first way is algebraically, and we actually just did that here. We added the x pieces together, we added the y pieces together, and then we found the magnitude and direction that way. We're going to come back to that idea on Friday. The other way to do it is graphically, and that's what we're going to do today and Wednesday. So to find the sum or difference of a bunch of vectors graphically, we're going to use a process called the head to tail method. And the reason it is called the head to tail method is we are going to string the vectors in a big long line with the head of one vector touching the tail of the next vector. So, the head to tail method, and we'll do a bunch of examples. When we add vectors, we place the tail of the second vector, the thing I am adding, at the head of the first vector. So I've got 2 vectors in the coordinate plane. I'm going to pick up the second guy and shift him so that his butt is at the head of the first guy. And I'm going to scroll up so we can see what this looks like. If I look at my path here, I can see that my first vector when I left my house was this. My second vector's tail starts where my first vector left off and then goes up. That's what we mean by head to tail. So where the first vector ends, the second vector starts, head to tail. And that pattern follows for however many vectors we want to add together. The tail of the third vector would go with the head of the second, and so on and so on and so on. Yeah. Where the first one ended, the second one starts. Where that one ended, the next one starts. The answer, the resultant vector, is drawn from the tail of the first. Where did I start my drawing? Where did I put my pencil down? To the head of the last. Where did I lift my pencil off the paper? And I'm going to go back up. We're going to look at that picture we drew. I can see first vector. There's my head of the first vector. Tail of the second starts at the head of the first, goes up. Tail of the third starts at the head of the second. My answer started at the tail of the first, pointed to the head of the last. All vector addition is going to look like that. We are going to practice it for a couple days because it's going to feel weird at first. We haven't done math with things that have direction before. I see some unhappy looks. Do we have questions? Lingering thoughts? No, we're all brain dead and ready to go home. Okay, one note, and then we're going to do a couple examples. Yeah? Okay, so first is if we are subtracting, we are going to rewrite it as an addition with negatives. So for example, if I want to do a minus b, I'm going to treat it as a plus negative b. And when I have a negative vector, I need to flip the direction. And I will give you an example so you can see what that looks like. So if this is vector b, minus b is going to be same length. It's going to have the same slope, but the arrowhead's going to be on the opposite side. So negative b, same length, if I could draw properly, would have the same slope, but the arrowhead's on the other end. So when we say flip a vector, that's what we mean. Same length, same tilt, arrowhead's on the opposite side. Yeah, we're literally picking it up and flipping it about its midpoint. Once you've flipped the negative guys, it is the head to tail method. We're going to try 2 now, and we'll finish the rest of 2C on Wednesday. Yeah? Okay. So I'm going to scooch you up. We have 3 vectors, B, G, and V. They're drawn here in their standard form, right? These are the position vectors for B, G, and V. So I can see that B, if I were to write him in standard form, what would vector B look like in standard form? 1, 3, very good. Over 1, up 3, perfect. What would the standard form for G look like? 2, negative 1, very good. What would the standard form for V look like? 1, negative 3, very good. That's going to help us draw them, because that is where the tail is relative to the start of a vector. That's going to help us draw. And the first example says I want to do B plus G plus V. Yeah? I'm going to count by 3s on my graph because the grid is tiny and I want this to be big enough we can see. And you'll notice I'm not numbering it. There is no origin here. This is just a grid. This is just so I can make sure my vectors are the right length. So I'm going to start with B. Yeah? I'm going to put B right here. That's the tail for B. To draw B, it says go 1 box to the right and 3 boxes up. So 1 box to the right, 3 boxes up. I just want a line, guys. Why can't I draw a line? Can I draw a line? Yes, I can. Oh, look at that. That is nice. That makes me happy.
Is that you?
No, I just remembered where that was stashed. So this is vector B. Tail, 1 box over, 3 boxes up. 1 over 3 up, 1 over 3 up. Yeah? I'm just copying vector B onto my grid system. So far, so good? The what, how, what? What watermark? I don't know. I don't know what you're talking. Oh, the citation? Yeah. All right. So to do B plus G, I'm now going to draw G, and G's butt is going to start where B ended. So my pen is now sitting at the head of B. And to draw G, I need to go 2 to the right and 1 down. So 1, 2, and 1 down. I started at the head of B, and I followed the directions on how to construct G. So right now I've got B plus G. Now I'm going to draw V. V's tail starts at the head of G. So to draw V, I'm going to put my pen the head of G. And to draw V, it says go to the right 1 and go down 3. So to the right 1 and down 1, 2, 3. And the question is, what does my resultant look like? How do I draw my resultant? What's the direction for drawing the resultant? Beginning of the end. So tail of first to the head of the last. Very good. So I know my resultant should start here and end here. Should look like that. I'm going to check really quick in my head that kind of makes sense by looking at what the individual vectors did. So looking at vector B, how far did we go to the right? 1. How far did we go to the right for G? 2. So now I'm at 3. How far did I go to the right for V? 1. So 3 plus 1 is 4. So from start to finish, I should have gone over 4. 1, 2, 3, 4. That puts me where I'm supposed to be. That checks out. I'm going to do the same check vertically. So B, the first one, how much did I go up? 3. Next one, how much did I go up or down? -1. So I went down 1. Now I'm at 2. Last vector, go down 3. I'm now at -1. I should be lower than when I started. I am lower than when I started. So I think we drew that picture correctly. It checks out with what we know about each of the vectors separately. And in terms of adding vectors graphically, that's all they want. They want the picture. You don't have to find the length. You don't have to find the magnitude and direction. Draw the picture. That's it. Draw the picture. Reasonable? Doable? We got this. Okay. Using those same vectors, we're going to try another one. Next one says V plus G. V plus G. V plus G. And you can see I copied the vectors so we can still see them while we're working. They're the same vectors that were on the front side. Where is my name generator so I can pick on someone? Cecilia. I want to add v plus g. What should I do first? Find the plots out. So divide up my graph, or what am I finding in the graph? So where our first vector starts. Good. Okay. So I'm going to do the same thing. I'm going to count by threes. And we're starting with vector v. So I'm going to start up here at the top of the graph because I know v goes down. And when I want to draw v, Cecilia, how much should I go down? 3. So 1, 2, 3. And then how much do I go left or right? Right 1. Very good. So the head of v should be right there. Perfect. So vector v, basically copy paste v from there onto our grid. Yay. Dayanara. What do I do next? And point of v, okay, and then how am I going to construct g? Right, 2, down, 1, so right there. Yeah? Come on, pen, that is not what I wanted. There we go. So that's g. And I want the resultant of v plus g. Juliet, how do I draw my resultant vector? Oh, let's pick on your neighbor. Jackie, how do I draw my resultant vector? Jackie doesn't know. Melanie, can you help Jackie and Juliet? How do we draw a resultant vector? So top point to bottom point? Can I get a thumbs up if we agree? Very good. Resultant goes from the tail of the first to the head of the last. Perfect. So this vector represents v plus g. Happy face. Happy face. Okay, so that is more than enough information for one day. Yes? We're going to finish these together on Wednesday. Give you some time to ask some questions, do some examples. Friday, we'll talk about how to do this algebraically, and then I've got a team task for you to practice both methods of vector addition. For today, you have a list of things to work on. So first, is there anybody in the room who has still not finished their midterm 2? All right, if you are on that list, you are finishing midterm 2. You clear your desk of everything except your calculator, your cheat sheet, and your Chromebook. If you have finished midterm 2, you have a couple of things you could work on. You have 2 assignments due today. You have the law of sines and law of cosines worksheet. If that's not done, finish it before you leave today. Drop it in my inbox. You have the week 13 delta math from last week that's due tonight by midnight. If you are a stellar student who is on top of your game and all of that is done, you can get started on the week 14 homework in Delta Math because you now have information to get through like 2/3 of that. Yeah? All right, you've got the rest of the period to work. If you have questions or need help with something, let me know. Yes, you may.